In this video, I'll be sharing about topic 3, basic input and output. I'll be talking about accessing I/O devices and I/O handling approach. To start off, we will first touch on accessing I/O devices. We all know components of computer system communicates, but how? They communicate through the interconnection network. Interconnection network consists of circuits needed to transfer information between the processor, memory, and I/O devices. The I/O devices are connected to the interconnection network through the device interface or circuit, which provides means for data transfer, exchange of status, and control information. This device interface includes data, status, and control registers that can be accessed by the program instructions as if they were memory locations. Let us now move on to basic I/O handling approach. There are two types of I/O handling approaches: program-controlled I/O and interrupts. Now we will discuss about program-controlled I/O. For program-controlled I/O, mechanisms need to synchronize their transfer of data between the processor and the I/O device due to the difference in speeds between them. The solution to this need is the signaling protocol. The program will enter a wait loop and test the device status repeatedly, which is also known as polling. The program enters a wait loop in which it repeatedly tests the device status. Let me show you an example to give you a clearer idea of how program-controlled I/O is used in input process. In an input process, when the keyboard is pressed, the keyboard circuit places the ASCII encoded character into keyboard data register, and the circuit will set the K-in flag to 1. One means that content is placed into keyboard data register, while 0 means that there is no content placed. When the processor that constantly polls the status of K-in flag detects that K-in is set to 1, it transfers the content of keyboard data into a processor register. Once the contents of keyboard data are read, K-in flag is cleared to 0 by the interface circuit so that the same data will not be read twice. If a second character is entered, K-in is again set to 1 and the process repeats.
Similarly, in an output process, such as displaying words on screen, in order for display data register to receive character from the processor, status flag DOUT has to be set to 1 to indicate that it is ready to receive character. After the content is being displayed, the circuit will then automatically clear the out flag.
The disadvantage of this approach is that the polling process involves the continuous involvement of the processor in I/O activities, which wastes processor execution time. To avoid wasting this time, we use interrupts. While waiting for the I/O to be ready, the processor can perform other useful tasks and arrange for the I/O device to alert the processor when it is ready by sending a hardware signal known as the interrupt request signal to the processor. When an I/O device sends this signal, the processor suspends the program it is currently executing to service the I/O interrupt with a separate routine. But until then, the processor performs useful tasks. We can understand interrupts more using this example. In a classroom, a teacher can be viewed as a processor and the students as I/O devices. When the teacher is teaching, he or she is performing useful tasks until a student interrupts by raising his or her hand. The teacher will then suspend the lesson to answer the student's question. Upon finishing, the teacher will go back to teaching. I hope that would make the concept interrupts clearer. So in this video, we talked about accessing I/O devices, program-controlled I/O, and interrupts. That's all, and thank you.